We are now going to take a look at section 4.3, addition and subtraction. Addition and subtraction of rational expressions. In other words, the addition and subtraction of fractions. Very important. Fractions can only be combined, added or subtracted, when they have the same denominator. That is just the most important thing. We have to, whatever problem we're doing, we have to make sure we have the same denominator. Okay? For example, in this first problem, you see that the two fractions have the same denominator. So that's, you say that. Do the two fractions have the same denominator? Yes, good. Therefore, you can combine these two fractions. And what you get is x plus 5 divided by x plus 5. And you know what comes next. You know that we can now cancel everything out, and the answer is 1. I won't even say are there any questions, because I think you see that pretty well. Next problem. Okay, well, let's assume that this negative belongs to the y. And do they have the same denominator? They do. Therefore, we can combine negative y plus 7 over y minus 7. Aha! Where are we? We're back to where we were a little while ago during the class, and that is this type of expression, where the y's have different signs, the 7's have different signs. So you can do this problem by factoring out the negative 1 from here, and this becomes y minus 7 over y minus 7. Okay, this is one of the first things we did way back when we first started doing reducing fractions. And therefore, the answer to this problem is negative 1. Okay? Let me give you a problem for you to try. Well, the key aspect here, start at the beginning. Your first problem is you do not have the same denominator. However, it looks like this situation up here. X minus 7, 7 minus x. Therefore, it's to your benefit, most likely, you sort of brainstorm with this and see what you could, what makes sense. And what makes sense is that you want to factor out a negative here. So you factor out a negative 1, and that'll leave you with negative 7 plus x. Okay, now there's a couple of problems here. First of all, this is backwards from that. So in order to make this look good, I'm going to modify it in my own mind. First of all, that negative I'm going to put over there. Okay, that negative down there is doing no good for anybody. However, if we put that up on top, then that's where it belongs. So let's put the negative over there. We have 4x plus 21 and let's take this and switch it around. And this is what we have. And now let's combine them, I guess. So let's extend this out here. Let's center this a little better. than it is. So let's put this over here like that. Now, this negative that I put up there really belongs to this whole thing. It just doesn't belong to the 4x. It also belongs to the 21. So this would become negative 4x minus 21. Okay, make sure that that's clear to you how we went from here to here to here to here. This is where we are right now. This was step one. This was what we were given. This is step one, which is factoring out the negative one. This is the next step, which is, kind of cleaning it up a little so that the negative is not down there, but over there, because we don't need it down there anymore. We need it kind of in the middle or on top. So let's move that negative there. And the negative 7 plus x, let's make into x minus 7. And this is where we are now. And now, in this state, we can factor the numerator.
Professor,
Yes.
what if I factored out -1 from the x minus 7 that's below? Yes. Would I have to factor out a -1 from the x squared as well?
No, what would happen is you'd be very, very messed up. Could you do it that way? Absolutely. Do you want to do it that way? No, you don't. That's my opinion.
Yeah, because after that, what I found was x squared plus 4x plus 21 over 7 minus x.
Yeah, you'd be dealing with a negative x squared. You don't want to do that. Anyway,
Okay,
I
okay,
like the way x minus 7 looks. I don't like the way 7 minus x looks. But
okay.
that's a personal thing. Do you understand what I mean?
Yes, I do.
I mean, who would you rather have lunch with? X minus 7 or 7 minus x? It's just a personal thing. I'm going to change this to look like that. I'm used to having my x minus 7. I'm not used to having my 7 minus x. And, when you get down here, that one of the factors is going to be x minus 7, and then the other factor is going to be x plus 3.
Okay, I see what you mean.
See, and then there it is. That's it. That's it. And the
So
answer,
it's just a question of determining what will be easier in the end.
exactly. It's helpful in making the problem as easy as you can. Now, I have a lot of experience. You don't have anywhere near the breadth of experience that I have.
Yeah, that too.
So, so I know that it would probably flow not more nicely if you do it this way rather than doing it the other way. But you have the math ability certainly to figure it out eventually, but you want to make it as easy as possible for yourself. And that's the answer to the question. I mean, did you actually get an answer?
No, I stopped at whatever I had because it didn't.
Yeah, no, I don't suggest it. I don't suggest that at all. Okay? All righty.
Thank you.
You're welcome. Let's do one more. Actually, I should have done this first because it was well, I don't know, maybe it wasn't so easy. It's incumbent upon me to do the more difficult problems. because, so we are doing some of them in, all right, I see, okay. I don't know. I'm looking at the problems. I just want to make sure. Okay, let's do this problem. This is problem S in the same category. So this is 3x plus 2y over 2x minus 3y. This is a nice challenging problem. I mean, they all are, but I think you could see what's going on here. 2x minus 3y, 3y minus 2x. So obviously, what we want to do first is move this around. See, if for some reason I always look at the second one. I mean, some people might say, all right, leave that alone and let's do it with this one. But I'm not. I'm going to be doing it with this one. Okay, now what we do next is obvious. It should be obvious based on what we've been doing. So 3x plus 2y over 2x minus 3y minus, keep the x minus 8y above there. Now, factor out a -1. And that'll give us 2x minus 3y. There's the common denominator. 2x minus 3y, 2x minus 3y. The problem is, what do we do with all these negatives now we have hanging around? We have a negative there, we have a negative over there. That's the question. And what I would suggest you do, does anybody know what you would do?
It will become a positive.
Wait a minute. Two people spoke at the same time. Who was Fama? You spoke. Let's let who I think Kadiatu. You were speaking too, right?
Yes,
Okay. What would you do? What would you do?
bring the sign up and add it's gonna be plus.
Excellent. That's exactly right. Beautiful. You take this, and you put them together. And you wind up with 3x plus 2y over 2x minus 3y. Okay, that's good. This negative and that negative would become positive. These little, I won't call them tricks because they're not tricks. They're just, insightful steps that you would take to make the problem a little more palatable to do. Now we have the same denominator, we have a plus sign, everything is as good as it could get. And now we want to combine the two fractions. So we get 3x plus 2y plus x minus 8y. And let's see what happens. Let's combine like terms. 3x and x is 4x. 2y minus 8y is -6y over 2x minus 3y. Huh. It's very, very nice. The problem is not over. Because we could factor a 2 in the numerator. Let's do that. 2, and you're left with 2x minus 3y, duh, right? And then 2x minus 3y. And these drop out, and the answer is 2. Very nice, huh? Really, really challenging. I mean, you know, you have to you have to know your math. But, you know, it's not that overwhelmingly difficult because we've been doing this type of problem. We did it up here.
Professor, can you put it up a little?
Oh, yeah, it's hard to get the whole thing in. That's the problem with the answer as well. Let me do this. The best I could do. And just say the answer here is 2. Does that help? So in other words, you're factoring out the 2, I mean the negative, factoring out the negative, there it is. And then you have the 2 negatives, which obviously is going to give you a positive. You combine everything, you combine like terms, you wind up with this. You see there's a factor of 2 here. And then, you know, these are the same. You cancel them out, and there it is. Very, very nice. Very, very nice problem. Okay? Anybody have anything they'd like to say? The number.
Can we do another one? Like,
No, we're moving on to something a little more difficult. I'm sorry. We
More
have,
difficult.
yeah,
I mean, it's
I
okay.
feel terrible. I feel terrible. Well, I mean, we can't stick with the same denominator. Wait, let me put it this way. There's problems in the homework. There's 3 problems in the homework on this topic. Let me see if it's 3. There are 3 problems in the homework just on this. Do it, and then we'll do it tomorrow when we start the class. But right now, we have to go on to adding fractions without the same denominator. Okay, so we did the same denominator. Very nice. I should have left that. Too late. I've already erased it. But you know that you cannot add fractions unless they have the same denominator, right? I mean, if you like the previous chat, section we just did, you're gonna love this. This is the culmination of everything, really. So let's take a look at this. This is different denominators. The other one was, the same denominator. This is different denominators. And the goal here is you must get both denominators, both. See, I know my math, but I don't know my spelling, right? Both. You must get both denominators to be the same. This is the issue. You must get both denominators to be the same. That's the key. And we'll start out with a relatively easy problem. Yes. Problem, these are page 47. And this will be problem C. And the problem is 8 divided by a times a plus 5 plus 4 over a. So what we're looking for is the least common denominator. There it is. The least common denominator. The least common denominator must have everything the old denominators had. This denominator has an A. The least common denominator must have an A. This denominator has an A plus 5. Therefore, this denominator must get an A plus 5. Now, they have the same denominator. Is that clear what I just did? Because there's an A there, there has to be an A. And because there's an A there already, we don't have to put two of them. We could use the same one. This one has an A plus 5. Therefore, we have to have an A plus 5. And now we're ready. Now, this denominator is exactly the same as this one. So we don't do anything. We just bring this down, and that's what it is. But this fraction has to be modified to look like that fraction. How do you get this to look like this? You have to multiply by A plus 5 over A plus 5. You have to multiply by the same thing, right? Because you're multiplying really by 1, and when you multiply a fraction by 1, you don't change the value of the fraction. So that's why we're multiplying by the A plus 5 over A plus 5. So what do we get? In the denominator, we get exactly what we want, but in the numerator, we get 4 times A plus 5. And you can see that if I covered this, you'd be back to the original fraction. Okay, now let's combine 8 plus 4, and you can actually start multiplying. Well, let's not. Let's go slowly, one step at a time. This is where we are now. We've now put the two denominators together, so we only have one. We only need one now because the denominators are the same, and we add the numerators. 8 plus 4 times A plus 5. And this will give us 8 plus 4A plus 20 over A times A plus 5. Now, we still have to simplify this even further. We want to go even further with this, right? So we get 4A plus 28 over A times A plus 5. Checking my work. I don't think you could do anything here either. I mean, obviously you could factor this, right? So you could factor this into 4A plus 7 over A times A plus 5, which is good. I mean, it's good to factor everything. But that's it. That's all you could do. This is the answer. When I circle something, that means that's the answer. Problem A. I know we're going from C to A, but I like problem A. 4x plus 1 over 2. Whoops. Don't want to do that. Started to do the problem there a minute. 2x minus 10 minus x plus 3 over x minus 5. Okay, do that problem, please. So we're going to factor the denominator. That comes first. I hope you realize that. Minus x plus 3 over x minus 5. Now, the goal is to find the least common denominator. There's a 2, we have to have a 2. There's an x minus 5, we have to have an x minus 5. And it's convenient because we also have one there, obviously. So now the question is, you look back at the original fraction, you look at the new fraction, is there anything missing from these two denominators? No, it's the same exact thing. Therefore, just write 4x plus 1. And here, is anything missing between here and here? The answer is yes. The LCD has a 2. This doesn't have a 2. Therefore, we have to multiply the numerator by 2 and the denominator by 2. So therefore, this becomes 2 times x plus 3. That's the critical step in this problem. Creating two fractions with the same denominator. All right, now, so the denominators are the same. We can combine the two fractions, and we have 4x plus 1 minus, now it's not just, now this minus goes for this whole thing. So it's going to be minus 2 times x plus 3. The minus signs are the things you really have to watch out for. So let's see now what we get. We wind up with 4x plus 1 minus 2x minus 6. I'm using the distributive property. And divided by 2x minus 5. In the numerator, combine like terms, you get 2x minus 5 over 2 times x minus 5. That's the end of the problem. I know it looks like you could do something. You'd like to do something, but really you can't. The only thing you could do is if you multiply the denominator, you know, the 2 times x minus 5, this is what you get. You get 2x minus 10, and you can't do anything.
Professor, why
Yeah.
can't you do that?
You could do it. I don't mind.
No, I mean make it 2 parentheses x minus 5.
Why can't you do here 2 times x minus 5?
Yeah, because that's what I initially was instinctually, I thought that's what you meant when you said, I know what you want to do, but you can't do that. So I'm asking, why can't we do that?
No, that's not what I meant when I said I know you want to do it, but you can't. This is what I think you want to do. But you can't. That's what I meant when I said I know you wanted. I know you want to put them together, or just leave it like this and cancel out the 2's. Or you know, when I first looked at this answer, I've done this problem like for the past several years. When I looked at this problem, I said, wow, look how close they look, right? Maybe we could do something. So I multiplied out and I said, well, obviously you can't. This is it. The answer to this problem is either this or, you know, if you want to, you could multiply out, but I think it's best always to leave it in the factored form. So that's the answer to the question. Okay. And let's do another one. How much time do we have? We'll see how far we got with this. Let me pick a nice problem. We may end the class with this problem, I'm not sure. Don't know how long. Little hint, I couldn't resist. You saw this. Therefore, logically, it would seem as if if this existed over here, that this monumental trinomial would factor, and one of the factors would be the same thing. I'm just taking a chance. I haven't even factored it, but that's what I think. That's just a guess. Now, let me just sort of start this a little bit. So that's the reason I put that there, is because there was this factor there, and this worked okay. Now, all you have left is a 4t, and this must be a 3, because 5 times 3 would give you 15. Now, let's see if that gives you the negative 14. That's the problem. So, well, this has to be plus, because the negative times the positive has to give you the negative. Now, does the middle turn out to be negative 14? Negative 20, positives 6, negative 14. That's it.
Yes, Professor.
Yeah.
Yeah. Anybody? Yeah. All right. So I factored this, and I took the tip that this had to be, if that was there, it had to be there. So it was easy then to put the 4t plus 3. The common denominator must have the 2t minus 5, obviously. There it is. It has to have the 4t plus 3. Now, this is the same, so we can keep the 21 there. But this, to get from here to here, we have to multiply by 4t minus 3.
Professor, is 4t plus 3.
Yeah.
Wait. Oh. Right. Good. Good. Thank you.
You're welcome.
All right. Do I have, so this becomes 12t plus 9 plus 21 over 2t plus negative 5, 4t plus 3, which gives you 12t plus 21. Does this help? Which gives you,
30.
wait, factor out a 3, 4t plus 3. Yeah, there it goes, right? Yep. That denominator factors into that. Oh, no, excuse me. Sorry. Wishful thinking, huh? That's called wishful thinking. No,
No, it will be
doesn't work.
10.
Doesn't work. Wait a minute.
It was 30 instead of 21 because it's 21 plus 9.
Wait. Yeah. Yeah. Okay. My apologies. I was pushing it a bit. All right. Yeah. Well, I'm obviously getting to the end of the class in my mind anyway. And this goes here. I'm too lazy to write it. See what's happening? And this is 4t plus 10, which doesn't do anything. So you could take out a 2, take out a 6, right? So let's get the 3 out of there, and let's put the 6 times 2t plus 5. Oh, oh, are you kidding? Really? It's not 2t minus 5? Really? Well, not everything is, works out perfectly. I think that's the answer. Does anybody agree?
Yeah,
Yeah.
I think so too.
Yeah, I think that's it. And it's problem, oh, it's a beauty. It's problem K, 5K. And this is it. It's 8b squared over 4b minus 5 minus 2b minus 1. That's it. That's it. This is how I would do it. This is how I would do it. The whole problem is right here, in my opinion. This is where the whole, if you could settle this and make this look decent, then you got a fighting chance. So I think if you factor out a negative, because if you factor out a negative, this would be 2b plus 3, plus 1, excuse me. See that? This is equal to this. And does that make sense? Factor out the negative from the 2b and from the negative 1, and that's what you get. And then the least common denominator is 4b minus 5. So you need to multiply the numerator by 4b minus 5?
Professor, I have a question.
Yeah.
Why did we have to factor the numerator for the first one?
Why did we do this?
Yes.
Because I didn't know what to do with this.
So what about if we just add directly like the 4b minus
Yeah.
to the denominator?
You just want this to be negative 2b minus 1, and just stick a 4b minus 5 over there?
Yes.
Yeah.
You can't do it. You can't, because it's a whole thing up here. This is a whole thing. You can't, here, you would just be multiplying the negative 1. This would be negative b, 2b minus negative 4b plus 20. That's not what it is.
No, and not like that.
No,
Just take 2b minus 1 between parentheses over 1, let's say.
you mean make this. You mean make this into this?
No,
What do you want to do? See, this is where being in a classroom would help, right?
it would be, yeah. It would be 2b minus 1 over
Now, that's
4b
not
minus
2b
5.
minus 1. This is the original problem.
Yeah, that's the original problem.
Yeah, so what do you want, so what do you wanna do? You wanna just stick a 4b minus 5 there, and what are you gonna do with the, like, and then you're gonna put the 4b minus 5 over there,
Yeah,
and then what?
and then multiply the numerator.
I mean, how, like, you're gonna is this how you're gonna do it?
No, put in like 2
No,
minus 1
to
in
leave the
parentheses.
minus between the two fractions. And then just do 2b minus
But the
1.
minus, but it's not just a minus between the two fractions. It's a minus 2b and a minus 1 between the two. Like, how do you? It doesn't make sense to me. Well, I'll tell you what, you do it your way and I'll do it my way, and we'll see if we get the same answer. That's the only way. Okay?
Okay.
You do it the way you thought was right. I'm gonna do it this way, and let's see what happens. So I'm gonna continue. I'm gonna get 8b squared. I'm gonna get 8b squared, and now I need to multiply these two. So that's gonna be 8b squared, like that, and like that is gonna be negative 10b, and then this is gonna be positive 4b, and this is gonna be negative 5, yeah, over 4b minus 5, and that's gonna be 8b squared. Now you're gonna do this, negative 8b squared plus 10b minus 4b plus 5 over 4b minus 5. I don't need parentheses there. Yeah, a tough little problem. This cancels out. This becomes 6b plus 5 over 4b minus 5, which becomes, that's it. There's nothing you could do. I think the answer is this. Did you get that?
No, I got negative 14b plus 5 over 4b minus 5.
I stick by my answer.
Yeah, but my question is, the 2b minus 1
Yeah.
would be the equivalent of negative 1 times 2b plus 1 over 1.
Yeah. That's what I had.
Okay, then that's when I went wrong.
Well, what did you have?
I put, the thing is, I did not factor out the negative 1.
Yeah.
I just
Kept
considered,
Just kept
yeah.
it with this.
So on top of that one, yes, I just put a 1 below 2b minus 1 as a fraction. Yes, but that
Well,
minus in front of the
between
2b.
here? What's between here? A plus?
No, I just left that minus that's in front of the 2b.
Yeah, you don't know what to do with this negative. If you did this, it might work. I'm not sure. If you did that and kept it as negative 2b minus 1, it might work. But you have to,
Okay, I see what yeah, okay, I understand now.
I just like the way I did it. It's just personal preference. Okay, now the class is over.